Hey guys, welcome to Conceptual Geometry. In this video, I'm going to work out the solutions on the Unit 1, Day 11 work session. So you can check your work or you can fast forward to one of the problems that you're having issues with. Let's start with number 1. It says, which of the following represent the length of a right triangle? Show all work. So remember, in order for something to be a right triangle, the Pythagorean theorem has to work, which is a squared plus b squared equals c squared. So we're going to check each one of these. Choice 1, 2 squared plus 3 squared equals 4 squared. And what you're going to do is you're just going to put this into your calculator exactly the way you see it. 2 squared plus 3 squared, you get 13. And then over on this side, 4 squared, you can do that in your head or in the calculator. That is, 16. So those are not equal. That means no. Doesn't work. It can be a triangle, but it can't be a right triangle. Next, we've got 5, 12, 15, so same thing. 5 squared plus 12 squared equals 15 squared. And I'm going to throw this into the calculator, and that gives me 169. 15 squared is 225. Not equal. That one's a no. Choice 3. 2 squared plus 4 squared equals 6 squared. Put that into my calculator, I get 20. 6 squared is 36. Not equal. That's a no. So obviously by process of elimination, this one's going to work, but let's verify. 5 squared plus 12 squared equals 13 squared. 5 squared plus 12 squared, we already did it over in choice 2, but that's 169. And 13 squared is 169. So that works, yes. Choice 4. Question 2, find the missing side to the nearest tenth. So once again, we're going to be using this Pythagorean theorem. Why is that? Well, the symbol's missing, but this is a right triangle. Here are my two legs. So when I use Pythagorean theorem, remember these are the legs. And this is what's called the hypotenuse. Hypotenuse is always the longest side. So that's the longest side. It's always opposite the right angle. That's always the one by itself. We got 7 squared plus 16 squared equals x squared. And again, just put all this into the calculator. It gives you a number. That number is 305 equals x squared. And to solve for x, we take the square root. And I wish I could show you on the calculator how to do that right now, but I'm assuming you guys can all do that. You can ask in class if you need some help. But the square root of 305 to the nearest tenth, all right, is 17.5. Question 3, a little different question here because it's a word problem, but they're asking you to verify. It says for his DDP class, Juan must make a right triangle. He has measured the lengths of the sides of his figure, and they are shown below. Can he truthfully tell Mr. Oberst that his triangle is a right triangle? Give a mathematical reason for your answer. Well, if this is to be a right triangle, obviously this would have to be the right angle, which makes this right here the hypotenuse. And this would be one leg, and that would be the other leg. Well, a squared plus b squared has to equal c squared. We know the numbers, so we just have to plug these in here, and hypotenuse over here. If it works out, then yes, it's a right triangle. If both sides are not equal, then no, it's not. All right, so I've got 21 squared plus 35 squared equals 28 squared. Sorry, messed that up. It's looking weird. 28 squared plus 21 squared equals 35 squared, and that's better. So now, because these are my two legs, I'm going to put this into the calculator, and that gives me 1,225. And over here, 35 squared in the calculator is also 1,225. So yes, indeed it works. Give a mathematical reason. I would say yes, because a squared plus b squared equals c squared. You showed it with the numbers, and remember this only works in a right triangle. Question 4. The ratio of the measures of the angles of a triangle are 2 to 3 to 7. Well, this is kind of a tricky question. We haven't seen one like this yet, I don't think. Now, when we're given angles or sides or anything that are in a ratio, we'd like to give each one of those an x. Because obviously the angles aren't 2 degrees, 3 degrees, and 7 degrees, but they're in that ratio. So it's going to be 2 times something, 3 times something, and 7 times something. So the angles are 2x, 3x, and 7x. Now it's a very easy question, right? Because you guys remember the three angles of all triangles add up to 180. So I just have to make an equation with that. 2x plus 3x plus 7x equals 180. Combine all your like terms, that gives you 12x equals 180. Divide by 12, x is 15. Again, doing that in the calculator. But again, don't circle that. What does the question want you to find? What is the measure in degrees of the largest angle? Well, in this triangle, the largest angle is going to be the 7x. So for my answer, I'm going to do 7 times 15, which ends up being 105 degrees. All right, if you wanted to put it in the figure, you could put it in the figure over there. Okay, let's move on. Backside. Isosceles triangle ABC. B is the vertex. So remember how we like to draw these. Here's my isosceles triangle. These two sides are the same. These two angles are the same. B is the vertex. Remember, the vertex simply means top. So this has to be B. And it doesn't really matter where you put A and C. So we have triangle ABC. B is the vertex. And this question is really tricky. Probably the hardest one in the entire unit. I think it used to be on a test and nobody would ever get this right because it says the vertex angle measures 3 times. And at first you're thinking, oh, great, 3x. 3 times the sum, which means add, of the measures of the other two angles, which happen to be the base angles. So what I need to do first is make each base angle x. I'll do this in a different color. And then 3 times the sum. So that's 3 times x plus x, which is 3 times 2x, which is 6x. So this vertex angle ends up being 6x. Okay, well now I need an equation. The three angles of a triangle add to 180. So here we go. We've seen this over and over again. Going to see it over and over again. I've got 6x plus x equals 180. Add all those together. That gives me 8x equals 180. Divide by 8. And again, another reason this question's tricky, ends up being a decimal, 22.5. We're going to have decimals from time to time. That's why we use calculators on all these problems. So again, what does the question ask for? Measure of angle B. Angle B is 6x. So 6 times 22.5 is going to be 135. That's that angle. All right, moving on. Question 6. Isosceles triangle ABC. That's important. They don't label it. It says AB is extended to D, forming exterior angle DBC. AB and BC are equal. So AB and BC are equal. All right, well, let me mark those. Well, notice how that figure, let me scroll back up here, how this figure compares to this one. Basically, it's this one that's been rotated onto its side. So it's going to have two equal angles, and those two equal angles are here and here. I want to find the measure of angle A. So I don't know what angle A is. Let's call it x. Put an x here. Well, since these two angles are equal, and I just made this one x, well, guess what? I got to make that one x. Now, we have an exterior angle theorem, but I don't think we'll remember that for a whole year. So what I want you to do is remember something you should remember for the whole year, and that's that forms a straight line. So these two angles here have to add to 180. So to get this one, I just take 180 minus 130. Okay, 180 minus 130, that's going to go there, so that's going to be 50. Now another theorem I expect you to remember all year long is this one. The three angles of a triangle add up to 180. So I forget about that, don't need it. I've got 2x plus 50 equals 180. Subtract 50 from both sides. 2x equals 130. Divide by 2. X is 65. Let's just double check that answers the question. X is 65. Measure of angle A, we denoted with an X. So that is my answer. Last two. Total review here. Two parallel lines cut by a transversal. Look at the shape of each angle. So in this one, 6x plus 15, the shape of this angle is obtuse. shape of this 4x minus 25 is acute. These two are not equal because look at the shapes are completely different. So what I'm going to do, add them up and set that equal to 180. Okay, 6x plus 15 plus 4x minus 25 equals 180. Now I'm going to combine my like terms. I got 10x. That's going to be negative 10, right? 15 minus 25. Okay, so that gives me 10x minus 10 equals 180. So now I have to add 10 to both sides. A little bit unusual, but not difficult. 10x equals 190. Divide by 10. X is 19. Let's see what the question wants us to find. Find the value of x. Got it. Done. All right, our last question. This angle here clearly is obtuse. Look at the shape of that one compared to the shape of this one. Also obtuse. See, these two are the same shape. Therefore, these two will be equal to each other. I got 8x minus 68 equals 3x plus 47. So variables are on different side. Move the smaller one over. Take this number, move it over here. All right, I'm going to write it out, though, but I'm just kind of visualizing what we're doing. That means I have to add 68. Because remember, from algebra, I need these to cancel here, I need those to cancel there. So what I'm left with is going to be 5x there and some number there, that's 115. So I've got 5x equals 115, divide by 5. And x is going to be 23. Okay, is that the answer? No. Find the measure of angle W. There's angle W. All right, so that's going to be 8 times 23 minus 68. And again, you're going to throw all of that into the calculator. I got 116. Okay, and that's a wrap for this work session. As usual, guys, reach out if you have any questions. Thanks for watching.